Hello everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be covering trigonometry lecture 3. So basically we'll be studying compound angles, extended compound angles and some of the applications and results based on that. Now let's look at question 6 of the QOD series and just take a pause or take a screenshot, whatever you want to do, and solution will be uploaded tomorrow. So the important question arises is, why do we need compound angles? What is the need to derive them? So basically, let's say if I ask you what is the value of sine 75, or let's say what is the value of sine 15, you might not be able to answer because we don't really know how to derive these. Also, it's not really possible to geometrically derive these because these involves irrational numbers, a lot many irrational numbers, rather than just 1 by root 2 or 1 by root 3, something of that sort. So that is why we have to derive them with the help of the existing formulas which you already know. So when I write this, I really don't know how to derive it, but when I write it in this manner, 45 plus 30, then it sounds possible that, okay, we might do something because we know sine of 45, we know sine of 30. So it sounds possible. So that is why we have to study about compound angles. Now let's look at the first derivation. I'll do just one derivation because the derivation part is not really important. Important is the application and the problem solving. So we'll do that a lot more rather than deriving all the formulas. We'll derive just one formula and we'll remember the other formulas. Now let's look at this diagram. So we have x and y axis. We have two rays. Let's call it as first ray. Let's call it as second ray. So this particular ray, this ray 1, is at an angle A from x-axis. Ray 2 is at an angle B from ray 1, right? So basically, ray 2 is making A plus B angle from x-axis. Now let's write sine of A plus B, right? Now, since this is a geometrical proof, so I have done some constructions, and these constructions are as follows. So firstly, I have considered one point C. It's a random point, it's not a fixed point, it's a random point. Let's take it over here. And what I've done is I've dropped perpendiculars on x-axis and on ray 1. That is basically I've taken a point on ray 2 and I've dropped a perpendicular on ray 1. It doesn't look like that because of the drawing, but it's actually a perpendicular, right? So we have dropped two perpendiculars from C. Why I'm dropping perpendiculars? Because this is a trigonometrical proof. So basically this is a geometrical proof of a trigonometric formula. So basically we need right angle triangles to prove that. That's why I've been dropping perpendiculars. Now let's make another construction. So I have got this point as D, this point as F, and let's make two perpendicular drops from D. So this is the first one and this is the second one. I have got E as this one and G as this one, right? So these are the four perpendicular drops I have made. Now let's write sine of A plus B in terms of this diagram, right? So that is nothing but we'll have to consider OCF triangle, right? So based on that, sine of A plus B is nothing but CF divided by OC. Now I can write CF as CE plus EF divided by OC. Now I can see that EF is same as DG, right? Because these are perpendiculars. So this is a rectangle. So EF is same as DG. Now I'll write CE plus DG divided by OC. Now let's look at the first part, CE by OC. But I don't really get anything useful from that because CE is over here, OC is over here. That ratio is nothing in geometrical terms, right? So to make that useful, what I'll do is I'll write it as CE by CD divided by CD by OC. So I have multiplied and divided by CD. CD is this. Why I've done that? Because this CD is common in both COD and CED triangles, right? That will make much geometrical sense and trigonometrical sense. So that is nothing but CE by CD. Okay, now let's look at this one. So we have got this angle as A. So basically this angle, this particular angle, this is 90 minus A because this is 90 degree. So this should be 90 minus A. And these two are vertically opposite angles. So that should be also 90 minus A, right? Now consider this triangle CD, let's call it as H, CDH. In that case, this is 90 degree. This is 90 minus A. So that should be angle C should be A, right? So basically CE by CD. CE by CD is nothing but cos A. Now CD by OC. Now let's consider this triangle OCD. CD is this one and OC is this one. This is 90 degree. So basically OC is hypotenuse and CD is base corresponding. CD is sorry perpendicular base corresponding to this angle, right? So that will give me sine A. Sorry, sine B, right? So we have got the first part cos A sine B with this CE by OC. Now let's look at DF by OC. Sorry, this is DG actually. DG by OC. Okay. Now again, that doesn't make any sense because DG is over here, OC is over here. That doesn't make any geometrical sense. So what I'll do is, this is OC. So what I'll do is, I'll see a commonality between these two. So that is OD. OD is common in this triangle and OD is common in this triangle as well. So I'll divide and multiply by OD. So what it gives me, DG by OD. This triangle is a right angle triangle. Corresponding to angle A, this is perpendicular, this is hypotenuse. So basically this is nothing but sine A. And in case of OD and OC, OD is corresponding to this angle, angle B. OD is base and OC is hypotenuse. So this is nothing but cos B. So we have got a formula sine A plus B equals to cos A sine B plus sine A cos B. That's what we already knew, right? Sine A plus B is sine A cos B plus cos A sine B. So this is the kind of derivation you can do for cos A plus B, tan A plus B. But I'll skip that because we just have to understand the application. We have understood the derivation part of sine A plus B. We don't really need to do the derivation of cos A plus B and tan A plus B, right? Now let's look at the formulas of these compound angles. So sine A plus B is sine A cos B plus cos A sine B. Cos A plus B is cos A cos B minus sine A sine B. And similarly, you can add a minus sign over here and you can derive these two formulas. So that will come out to be sine A cos B minus cos A sine B in case of sine A minus B. And in case of cos A minus B, it will come out to be cos A cos B plus sine A sine B. Yeah. Now let's look at formulas of these compound angles as well. So tan A plus B is nothing but tan A plus tan B divided by 1 minus tan A tan B. So this is the formula for tan of A plus B. Now for cot of A plus B, what you had to do, you just had to do the reverse, right? So that will come out to be cot A cot B minus 1 upon cot A plus cot B. Now formula for tan A minus B is pretty easy because you just have to apply minus sign over here and plus sign over here. So that's very easy, but cot A minus B is a little tricky. So that will become cot A cot B plus 1 upon cot B minus cot A. So it's not cot A minus cot B. It will become cot B minus cot A. So that you have to remember. So this is a not tricky part, but you might forget it. Now let's look at this question. If A plus B is pi by 4, find the value of 1 plus tan A into 1 plus tan B. So what we have been given is 1 plus tan A dot 1 plus tan B. So what I'll do, I'll multiply it. Now I can see that after multiplying this, I can see that we'll have a term of tan A plus tan B plus 1 plus tan A tan B. So I can get a feeling that I might have to use tan of A plus B or tan of A minus B, right? So that's how we are going to proceed. So this is 1 plus tan A plus tan B plus tan A tan B, right? This is our multiplication. Now we know that tan of A plus B equals to tan A plus tan B divided by 1 minus tan A tan B, right? Now we know that A plus B is pi by 4. So basically tan of 45 is nothing but 1. So what we get is tan A plus tan b equals to 1 minus tan a tan b. So now I see that I can replace this in this equation. So basically what we've got is from here 1 plus 1 minus tan a tan b plus tan a tan b. So this gets cancelled out. So we have got 2 as the answer. So D is the correct option. Now let's look at another example. If tan 70 equals to tan 20 plus k times tan 50, then k is equals to. Okay. So what we'll do, we'll write tan 70 as tan 50 plus tan 20, right? That's how we are going to proceed. We don't have any other clue. 20, we see 20 plus 20 and 50 over there and 10 70 over there. So I get a feeling that, okay, writing tan 20 plus tan of 20 plus 50 might do something. So what we'll get is tan 50 plus tan 20 divided by 1 minus tan 20 that dot tan 50. This is equals to tan 70. Now one can get stuck over here because there is no way that we can write this in linear form unless we know something else, right? Because this is tan 70. In our equation, this is a linear equation in terms of tan 20 and tan 50. So tan 70 equals to tan 50 plus k times tan 50. But we don't see anything of that sort. So something might be missing, right? So what is happening over here? We see that 20 and 70 are complementary angles. So basically 20 plus 70, 20 plus 70 is 90. So I get to know that if I multiply it over here, I'll get something. So what happens is tan 50 plus tan 20 equals to tan 70 minus tan 20 dot tan 50 dot tan 70. Now I can write tan 20 as cot 70. This is nothing but cot 70. So this and this get clubbed and that will become 1. So now this will become tan 50 plus tan 20 equals to tan 70 minus tan 50, right? So basically we get tan 70 equals to 2 times tan 50 plus tan 20. So 2 is the correct answer. K value is 2. Yes. Yes. Got the point how to think about these questions. Now let's look at additional compound angles. So these kind of formulas or questions haven't been asked in PGDB yet, but just for the sake of doing it, we are doing it, and you just have to remember these formulas. It shouldn't be like you should ignore it. It might be possible that you get a question next year, so you just have the formula in your mind. They're not going to ask very tricky questions from here. So we'll write the formulas one by one. Okay, I cannot remove that. Okay, I'll write formulas for sine and cos over here. So the formula is very easy. So for sine of a plus b plus c is sine a dot cos b cos c plus sine b dot cos c cos a plus sine c dot cos a cos b. You get the pattern, right? First sine a, then for the remaining angles cos, then sine b for the remaining angles cos, sine c cos a cos b, right? So it's a repetitive pattern, so it's very easy to remember. Now in case of cos of a plus b, there is one additional term and a little bit changes in sign. So basically that will be cos a dot cos b dot cos c minus cos a, then same pattern, sin b sin c minus minus cos b dot sin a sin c minus cos c dot sin a sin b. So again, same similar kind of pattern. This is additional term and these are the negative signs over here. So these are very easy to remember. Now in case of tan of a plus b, It's a very lengthy formula, so we have written in terms of pi, sigma and pi. So sigma tan A is nothing but tan A plus tan B plus tan C. So if someone doesn't know these notations, so sigma tan A means tan A plus tan B plus tan C. If there were four angles, then we would have written tan A plus tan B plus tan C plus tan D. So sigma means that. Minus pi tan A. So again, same kind of notation over here, but in case of here, it's multiplication. In this case, it's multiplication. So pi tan A means tan A tan B tan C. So this is tan A plus tan B plus tan C minus tan A tan B tan C divided by 1 minus sigma tan A tan B. So this means 1 minus tan A tan B minus tan B tan C minus tan C tan A, right? So these are the three formulas you just have to remember. There haven't been any question in from these formulas in PGDBA, but just for the sake of doing it, you just have to remember it. Now these are few important results. Sine of A plus B dot sine of A minus B. You can derive it by expanding it, but the formula comes out to be sine square A minus sine square B. For remembering this one, for recognizing this one, it's very simple. It's like A plus B and A minus B. That comes out to be A square minus B square, right? In regular algebra. So similarly, it comes out to be sine square A minus sine square B. And that is also equals to cos square B minus cos square A. We just converted 1 minus cos square, they convert this as 1 minus cos square B and this as 1 minus cos square A. We'll get this formula. Now let's look at this formula, cos of A plus B dot cos of A minus B. This I have written this as wrong. So this is cos of A minus B. So that comes out to be cos square B minus sine square A. And that is also same as cos square A minus sine square B. So you can write it in both the manners, because what you can do is you can just convert it into cos. So this is 1 minus cos square B and minus sine over here. So you'll get this formula, right? So remember any one of these. Now let's look at one example. If A plus B equals to pi by 3, then find the value of cos square A plus cos square B minus cos A cos B. Now this is an interesting problem. Let's look at it. We have been given as A plus B equals to pi by 3. And what we have to find is cos square A plus cos square B minus cos A cos B. Now, how to start this particular question? So what should be your approach to make it more efficient? So there can be multiple ways, but we have to choose the efficient one, right? Now, what I might do is I can write it as cos of A plus B equals to 1 by 2, and I can expand it. Now, what this will do is I'll get rid of cos A cos B, but I'll get an additional term of sin A sin B. And I don't see anything useful of sin A sin B over here. So this is not the correct method. And even if it might be, we'll have to do multiple adjustments and multiple correlations over here before getting to the right solution, right? Now, what I can do, I can write A as pi by 3 minus B. And now I can use the expansion. I can replace A with the pi by 3 minus B over here and over here. But that will make the equations too lengthy, right? If I write pi by 3 minus B over here, then what I'll have to do, I'll have to first open this cos of pi by 3 minus B with the help of cos A cos B minus sin A sin B. And then I have to square it as well. And over here as well, I have to multiply it with cos B again. So that doesn't seem to be an efficient solution. So one idea that hits my mind after looking at these angles A and B, since these angles are different, I can try to write it as sine square B plus cos square A, right? Because that will give me cos square A minus sine square B, which is cos of A plus B cos of A minus B, right? Sorry, yeah. Now I'll write it as 1 plus cos of A plus B dot cos of A minus B cos A cos B. Now I can clearly see that this is pi by 3. So that will become 1 by 2 times cos A minus B. So that is cos A cos B plus sin A sin B, right? Minus cos A cos B. Now again, that is favorable. because I'll plug it in over here. That will give me 1 minus 1 by 2. That will become cos A cos B minus sin A sin B, right? I've taken that minus extra out over, that's why minus over here. So that will become 1 minus 1 by 2 times cos of A plus B. So that becomes 1 by 2 dot 1 by 2. This is 3 by 4. So 3 by 4 is the correct answer. Right? So you got to understand how to approach these questions. They might seem easy at first, but the wrong approach might lead you nowhere, and you might end up skipping the question. So today's lecture was till here only, and in the next lecture we'll study about multiple submultiple angles, and after that we'll study series transformations. So let's meet tomorrow for the next lecture. Thanks for watching.